Brother, inside your body, millions of chemical reactions happen every second. Your blood is more than a transportation system. It is a carefully balanced environment where pH, oxygen, carbon dioxide, and electrolytes must remain in harmony. When that balance shifts, your blood vessels respond. They widen, they constrict, they accelerate flow, or they slow it down. Most men focus on diet, supplements, and exercise, but very few understand that blood pH, the delicate balance between acidity and alkalinity, plays a crucial role in vascular performance. This doesn't mean alkaline diets cure everything. That is not the truth. What is true is that your body uses natural buffering agents to maintain stability. And among those agents, sodium bicarbonate has a unique role, not as a miracle solution, but as a physiological tool your body already uses internally to regulate acidity. Before we discuss how sodium bicarbonate interacts with vascular function, we must first understand this hidden system that supports circulation, endurance, and nitric oxide signaling. Your blood must stay within a narrow pH range, 7.35 to 7.45. Even slight changes in acidity affect oxygen delivery, muscle fatigue, and the ability of blood vessels to expand and contract effectively. The body regulates pH using three major systems: respiratory system, breathing out carbon dioxide to reduce acidity; kidneys, filtering acids and bases to stabilize balance; chemical buffers, including bicarbonate, proteins, and phosphates. Sodium bicarbonate, or bicarbonate in general, is part of your natural buffer system. Its job is simple: neutralize excess acids, prevent dangerous pH drops, maintain optimal blood chemistry, and support consistent circulation during physical stress. In intense exercise, muscles produce lactic acid. This makes your blood more acidic, which can reduce performance, tighten blood vessels, and slow nitric oxide production. Bicarbonate's buffering ability is why scientists have studied it for decades as a tool for improving endurance. Not for sexual performance, not for miracle health effects, but for biochemistry, for pH stability, and for vascular efficiency under physical stress.
When sodium bicarbonate enters the bloodstream, it increases the concentration of bicarbonate ions. This does not alkalize the blood dramatically. Your body tightly controls that. Instead, it influences how your body handles acids during stress. Here's what actually happens. Bicarbonate neutralizes excess hydrogen ions. This reduces acidity during high-intensity exercise. Blood can carry more carbon dioxide. Muscles delay fatigue. Blood vessels stay more relaxed. Oxygen delivery remains efficient. This is why endurance athletes, under medical supervision, have used bicarbonate strategies in sports science. But the effect is indirect. It does not force blood vessels open. It does not explode nitric oxide. It does not treat vascular disease. It simply supports the environment where the vascular system can work more effectively under physical demand.
Nitric oxide, or NO, is a crucial molecule in our bodies, acting as a vital messenger that signals blood vessels to relax and widen. This process, known as vasodilation, is fundamental for maintaining healthy blood flow throughout the entire circulatory system. The importance of nitric oxide extends far beyond simple blood vessel relaxation. It is essential for a multitude of physiological functions. Firstly, NO is critical for optimal circulation, ensuring that blood reaches every tissue and organ efficiently. Secondly, it plays a direct role in oxygen delivery, as wider blood vessels allow for more efficient transport of oxygen to working muscles and vital organs. This enhanced oxygen supply is particularly beneficial for athletic endurance, enabling sustained physical performance and faster recovery. Beyond performance, nitric oxide is a cornerstone of overall vascular health, protecting arteries from damage and promoting their flexibility. And for men, NO is also crucial for male performance, directly impacting erectile function by facilitating blood flow to specific tissues. However, the body's ability to produce nitric oxide is not constant. It depends on several interconnected factors. One key factor is oxygen levels. Adequate oxygen is necessary for the enzymatic reactions that synthesize NO. The health of endothelial cells, which line our blood vessels, is also paramount, as these cells are the primary producers of nitric oxide. Enzyme activity, specifically the efficiency of nitric oxide synthase enzymes, directly dictates how much NO can be generated. And finally, pH balance within the blood and tissues significantly influences these enzymatic processes. When blood becomes too acidic, even slightly, the enzymes responsible for nitric oxide production work less efficiently. This isn't a dramatic, immediate shutdown, but rather a subtle yet measurable decrease in their activity. This reduced efficiency means less nitric oxide is produced, which can have downstream effects on vascular function. Therefore, maintaining a stable pH environment is crucial for supporting optimal NO production and signaling. A stable pH environment supports better nitric oxide signaling, ensuring that the messages for vasodilation are effectively transmitted. This leads to healthier artery dilation, allowing blood vessels to expand and contract optimally in response to the body's needs. The result is more consistent circulation, preventing areas of restricted blood flow and ensuring all tissues receive adequate nutrients. Ultimately, this translates to improved performance during activity, whether it's daily tasks or intense physical exercise. This is the true connection between pH, bicarbonate, and vascular function. It's not about magic or immediate, dramatic results. Instead, it's about biochemical optimization that supports a healthier environment for blood flow. By understanding and supporting this delicate balance, we can promote long-term vascular health and overall well-being.
Before discussing preparation methods, we must address safety. Sodium bicarbonate is not a harmless substance to be consumed freely. Excess intake can cause digestive discomfort, bloating, nausea, electrolyte imbalance, increased sodium levels, kidney strain, and worsen hypertension in sensitive individuals. Men with the following should avoid high intake: high blood pressure, kidney issues, heart failure, sodium sensitivity, and gastrointestinal conditions. Also, this is not a treatment for erectile dysfunction, heart disease, or vascular problems. Our goal is to educate, not exaggerate. Used safely in small, controlled amounts, bicarbonate can support performance during physical activity by supporting pH stability. Not more, not less.
To stay within safe, educational boundaries, we will present a general physiological protocol that is commonly referenced in sports science literature. This protocol is not as medical advice and not as a treatment for vascular conditions. The purpose: to illustrate how bicarbonate interacts with pH when used in controlled endurance contexts. General sports science protocol: a small amount of sodium bicarbonate mixed into water, taken slowly, before physical activity to support pH buffering. This is purely for understanding the chemistry, not for health claims. A controlled example often used in studies: 1/2 teaspoon dissolved fully in water, sipped slowly over several minutes. This avoids rapid spikes and supports manageable digestion. Again, heavy checkmark, not a miracle drink heavy checkmark, not a substitute for medical treatment heavy checkmark, not a replacement for real nitric oxide strategies heavy checkmark, not a cure for vascular issues, but a tool that reveals the concept of how pH buffering can indirectly influence endurance and vascular performance. And this is the entire point of this documentary: to understand the science, not to promise effects that biology cannot guarantee.